This is a video for 9.9, and in this video we're going to look at solving trig equations. So we're going to solve for theta either in degrees or radians, depending on the problem, and we'll look for any angle on the unit circle that satisfies the equation. So here we're going to treat this like any other equation, except instead of having a variable such as x, we're going to try to isolate the trig part of it. So the trig function sine theta is what we want to isolate. So to do that, we're going to subtract the root 3 from both sides and then divide both sides by 2. So we're trying to figure out what angle theta, the sine value would be negative root 3 over 2 in degrees. So sine is negative root 3 over 2 at the longest legs here and here. So we have 300 degrees and 240 degrees. This next one, letter E, we have cosine theta on both sides. So just like we can combine like terms when we have a variable such as x, we can combine like terms here as well. So if we add cosine theta to cosine theta, that's 2 cosine of theta equals root 2. Then we can divide both sides by 2. And we're trying to find what angles in radians cosine theta would be equal to root 2 over 2, positive root 2 over 2. So we can see here that the medium leg is positive root 2 over 2 at 45 degrees, which is pi over 4 radians. And also at 7 pi over 4 radians, we have a cosine of root 2 over 2. Alright, let's look at H. Tangent of theta equals 1. Well, we know sine theta over cosine theta is the same as tangent theta. In order for sine divided by cosine to give us an answer of 1, we know that these need to be the exact same value. So on the unit circle, we're looking for what angle, or angles in radians, would sine and cosine be exactly the same. So in this first quadrant, at pi over 4, cosine and sine are both root 2 over 2. So dividing them would give us an answer of 1. We want to look at the entire unit circle and see if there's any other spot where sine and cosine are identical. In this quadrant, we have a cosine of negative root 2 over 2 and a sine of negative root 2 over 2 at 5 pi over 4. A negative divided by a negative is a positive, so that would also give you a tangent of 1, 5 pi over 4. Some of the other problems at the bottom give you more of a restriction as to where we're looking for the solution on the unit circle. So for example, looking at 5a, if we're given sine of theta is root 3 over 2, and we're given this restriction that theta must be between pi over 2 and pi, we're looking only at the part of the unit circle that's between pi over 2 and pi. So in this quadrant, we're looking for a spot, an angle, where sine is root 3 over 2. That would only be at 2 pi over 3. If the problem's given in radians, you should write your answer in radians, and if it's given in degrees, like part B, you should write your answer in degrees. So between pi over 2 and pi, sine is root 3 over 2 only at 2 pi over 3. That is the angle. Once we know what angle we are at, we can find all of the other trig functions. So cosine of 2 pi over 3 is negative 1/2. Tangent is sine over cosine. So sine is root 3 over 2. We're dividing by the cosine, which is negative 1/2. Simplifying that would be root 3 over 2 multiplied by the reciprocal of this, negative 2 over 1. And this simplifies to negative square root of 3. Secant is the reciprocal of cosine, so that would be negative 2 over 1. Cosecant is the reciprocal of sine, so that would be 2 over root 3. Rationalizing the denominator, we need to multiply both the numerator and the denominator by root 3. So we would get 2 root 3 over 3. Cotangent is the reciprocal of tangent. So the reciprocal of negative root 3 is 1 over negative root 3. And here also we need to rationalize the denominator. So this would be negative root 3 over 3.